Alright, so we're back with Algebra 1, looking at our next section. So here's your warm-up. So factoring these polynomials. So take a minute and factor these two trinomials and see what you get. Okay, so we have these two trinomials trying to find our factors for them. So with the first one, you end up with your box and diamonds. It's pretty straightforward. Or you end up with just your diamond. You don't have to do your box. Okay, so remember with your box and diamond, you end up with 18 and a minus 9, giving you your two numbers as negative 6 and negative 3. So you end up with x minus 6 and x minus 3 as your answer for that one. Okay. Now the second one, there's two ways of doing it. One, you could do your box and diamond, or you could factor out a 2. So if you factor out a 2, you're left with x squared minus 4x minus 5. And then you just have to use your diamond on that one. So if you use a diamond on that one, it'd be negative 5, negative 4. Since the top is a negative, that means they're different signs. And since the bottom's a negative, that means the bigger number is going to be the negative number. Two numbers multiplied gets you 5, added gets you 4, or negative 5 and negative 4 would be negative 5 and 1, which means we have 2 times x minus 5 and x plus 1. Now, that's one answer, or you could have multiplied this 2 into one of the other ones. So it could have been 2x minus 10, or it could have been 2x plus 2. Okay, so if you had any of those answers, it would have been acceptable as well. Okay, so that's our factoring. So moving on to section 7, what we're looking at is we're going to be factoring special cases. So these are only certain times, like when we were multiplying them through, and you know there was like a shortcut we could use. This is going the reverse. So this is factoring these shortcuts. So the perfect square trinomials are ones that we could factor. Now, again, only special cases. If you square the first and square the last numbers, if they're perfect squares, and then we have the middle number is the multiplication of the 2 times 2. And if it's adding, it's a plus b squared. If it's subtracting, it's a minus b squared. So again, these are very rare. Okay, they're only very special cases in which they can be used. But you just have to, you know, if you remember them, you can do a problem a lot quicker by being able to use this. But again, you can't use it for every single one. So let's look at these examples. So if we look at the first example, is the first number a perfect square, x squared? Yes, it is. The first one is a perfect square. It would be x squared. Okay. Is the last number a perfect square? Yes, it is. It's 5 squared. So now, x times 5, so now we got to ask, is 2 times x times 5, does that get us 10? And the answer is yes. So that means that we end up having a perfect square, which we can write it as x plus 5 squared. And that's because this number here is positive. Okay, since that's a positive sign, we have the positive. So now if we look at the second one, exact same thing. The x is being squared, the 5 is being squared. In the middle, the only difference is that it's a negative, which means that we have our answer as x minus 5 squared. Okay, so we have x minus 5 squared. Okay. All right, so take a minute. I want to see if you guys will be able to find the perfect square binomials of this one, I guess. So take a second. You can pause the video and try to find the perfect square binomial if there is one. Okay, hopefully you did find it because it is possible. If we square root the first one, we get an x. And if we square root the last one, we get a 4. So now the question is 2 times 4 times x 8x? And that answer is yes. So that means that we do have our perfect square trinomial, and it would be x plus 4. Again, the two numbers that we ended up squaring, squared. Okay, so one works out pretty nice. So that's our perfect square trinomials when we're able to use them. And again, if you just factor this like you would with the box and diamond or any other way, you still would end up getting the same answer. Okay, these are just shortcuts that if you remember it, you can have an answer. Okay, so now with this one, as we notice, we see that the x squared is not by itself anymore. Now we have another number attached to it, but we can still do the same thing. What we end up doing is we end up taking the square root of the first number and the last number, and we want to know, are they perfect squares? 9 is, it's 3x, so it'd be 3x squared, and 4 is, it's 2, so 2 squared. So that means that this middle number has to be 2 times 3x times 2. And if it does equal that, then we do have another perfect square trinomial. And 2 times 3 times 2 is 12x, so that means that our number is, again, whatever's inside the parentheses after we've taken the square root of them. So as you see, it's that 3x and 2, we're just adding them together and squaring them. Okay. All right, so now the difference of two squareds. So if you have two numbers that are perfect squares and they're being subtracted, this one's a lot easier to see because obviously it's just going to be fairly straightforward. But if you have two numbers that are perfect squares that are being subtracted, they can always be written as a minus b and a plus b. Okay, because when you multiply those two together, that middle term, the b term in quadratics, it disappears. So if we take this one and we want to see, okay, are they perfect squares? Are both of these perfect squares? Is 16x squared a perfect square, and is 49 a perfect square? And the answer to both of those is yes. 16x squared is 4x, the whole thing squared, and 49 is 7 squared. So now we can write it out as two separate. And again, we use these numbers in the parentheses, these perfect squares, and one's going to be 4x minus 7, the other one's going to be 4x plus 7. And that's going to end up being our answers. Okay, so other times that we could see this is that if we look at this and we go, okay, do we get, are these perfect squared? So can we take the square root of 10x squared and the square root of 40? And do we get nice round numbers? No, we don't. Okay, we don't get nice round numbers, which means we can't really do it. But we can see, can we remove a greatest common factor? So is there something we can take out of both the front and the last one? In this case, we can. We can take a 10 out. And when we take a 10 out, we're left with x squared minus 4. And now we do the same thing. Can we factor that x squared minus 4? And that answer is yes, because x squared becomes x, and the 4 is a perfect squared of 2. So we end up with 10 parentheses x squared minus 4, and 10, and then the x squared minus 4 can be broken down to x minus 2, x plus 2. Okay. All right, so here's your homework from this section. It's section 7. Okay, so you are using these special cases when you can. Okay, so you want to look and see, can we use either of the special cases to solve? Sometimes you'll have to use your greatest common factor to remove it. And if you can't find, if it doesn't look like any of these special cases work, use your normal factoring. Okay, use the box and diamond or just the diamond to find your answer. It'll make life a whole lot easier, and then you might go, oh, it does work, even though it might not look like originally.